And so, we of course live in a mountainous province, and we live in a part of Canada that has a lot of landslides, and it actually has a whole range of other natural hazards. And that's why I like it. It's my playground, basically, because I'm very interested in all these phenomena that pose a risk to us. It's very interesting. We appreciate the beauty of the province, the mountains, the rivers, the glaciers, the landscapes that are developed around those landforms. But part of that, with that comes the possibilities of bad things happening. And we've seen some of those in recent years. The big flood, the atmospheric river event in 2021 is an example of a flood catastrophe. And so I kind of look at all these things, but tonight I want to focus on one in particular, which is landslides, as I mentioned. And it's not surprising, I think, when you think about it, that landslides would be common in a mountainous province like British Columbia. We are part of the Cordillera of Western Canada, and landslides are super common in all through British Columbia, parts of Yukon Territory, which are quite mountainous, and also westernmost Alberta. So I'm going to deal with that issue. And the first thing I want to talk about really is to talk to this. I'm not going to give you a lecture on types of landslides, although I will test you at the end. Don't worry about that. But there are many different types of landslides. So when we talk about the impacts of landslides on blocking streams, we have to kind of be aware that only certain landslides will do that. And this is a very simple classification of landslides by the mechanism at which they occur. So you can have a rock fall, for example. That's a problem along the sea to sky highway, very steep slopes, and individual blocks or small masses of rock where can collapse and kind of cascade down onto the highway and the rail line below. That would be an example of a rock fall. We can have slides, which are very common. That's where a larger mass of rock or soil slips away and under the influence of gravity moves down slope. And then we have flows, and that Lions Bay catastrophe, I call it a catastrophe because 2 people died, is an example of a flow where you have a small failure that is composed of loose soil, water saturated debris, commonly lots of woody debris, and it actually doesn't just slide down the slope, it actually transforms into a viscous flow that can travel at very high velocities, often for long distances. So the one in Lions Bay actually traveled quite a long distance, reached the highway, Highway 99, as we know, because we saw a lot of photographs of the blockage along the highway, and actually reached down to the rail line below. So I'm just going to illustrate these different types of landslide with some examples. And so these are examples of rock falls. Again, back before they upgraded the sea to sky highway, rock falls were very common, partly because the early construction practices, the blasting that took place along the highway to create these little notches in the rock that allow them to pave a road was inappropriate. It turned out it damaged the rock, set up a kind of a consequence of the rock failing in these types of events that you see at the lower right. And these are still quite common. The sea to sky highway is better protected now. If you think about it, as you drive along, you'll see a lot of wire meshing on these very steep slopes. Sometimes you can see these anchor bolts that have been driven into portions of the slope that are likely to fail, and they've reduced the number of kind of rock falls that occur. Because if you think about it, just a single block, even a small block that strikes a car can be fatal. And anyone who encounters, you know, a massive rock on the highway is going to have trouble avoiding a collision that's going to be very damaging and possibly injurious. So that's one type of landslide. We call them rock falls. These, well, I shouldn't say they don't have an impact on rivers and streams, because I'll give you an example in a while of one that had a huge impact about a century ago on salmon runs on the Fraser River. It was actually what you might call a small rock slide or a rock fall. It was human caused. It was caused by construction practices during the creation of the CN rail line at Hell's Gate. But normally these are too small to have a huge impact on our streams and rivers. We don't worry quite as much about them in that regard, but we do consider them to be hazards. And then we have rock slides. Now, rock slides are typically larger. They involve a large, massive rock that fails on a steep slope and runs down, typically the slope to its toe, and commonly into a valley. And if there's a stream in the valley, a massive rock that comes to rest will impound water behind it and create a reservoir. And this one that I showed here in this slide is an example of that. It's a rock slide on Vancouver Island, near the road from Port Alberni to Tofino, called Kennedy River. And that slide you can see has impounded quite a substantial body of water behind it. And if you think about it, those trees standing up out of the water are an indication that that reservoir has actually been created by the landslide that impounded the water behind it. That occurred in late 1970s, I think, or 1979. No one was injured. The lake is still there. So this is a pretty stable dam in terms of, you know, any sort of risk that is posed to people.
What is it? Is that what they now call Kennedy Bay?
Pardon?
Do they now call that Kennedy Bay?
Kennedy, it's near Kennedy Lake. It's the
Okay.
Kennedy River, I think, flows
Okay.
into Kennedy Lake.
Yeah.
It's off the highway. It's a semi-remote, but it's not far from the highway. So that's just an example, and it's an example of a dam that is fairly stable by nature of the fact that the material that composes it is large blocks, and the stream that would normally flow along that valley is a small stream. So water basically percolates through the debris mass, and it's stable for all practical purposes. Debris flows. I mentioned this phenomenon whereby a fairly small mass of soil can fail during heavy rain. And if it's on a steep slope, it will tend to slide and then transform into a flow as it moves down along a stream channel. And we saw that for the first time in British Columbia. I mean, we saw it for the first time. We didn't know what they were. But early on in the years of the Sea to Sky Highway, there were a couple of very disastrous debris flows around Lions Bay, one at Charles Creek and another right in the community of Lions Bay. So these were in the 1980s. And that they kind of led to a better understanding of the phenomenon. These aren't floods. And I think the engineers prior to the 80s thought of, you know, these kind of material blockages along roads of debris were a product of extreme rainfall and flooding. These are a different beast. They actually are landslides that are mixtures of debris of all sizes and force bleeding. So this is a photograph of that fatal landslide in, I think, in 1981. in Lions Bay that killed 2 teenage boys, very well, who were in a trailer along Alberta Creek. And Alberta Creek wasn't understood to have a potential debris flow hazard problem. And since then, there have been engineering to prevent that from happening again. However, Lions Bay continues to be at risk, as was shown by the event near Magnesia Creek late last year. This is a photograph of the track of that debris flow that came down a very small tributary of Magnesia Creek, not Magnesia Creek itself, but a small stream I never heard of before called the Ten. And I actually saw the source area inconsequential, just a very small mass of soil material, probably trees that had slid away from the slope, with a footprint less than the footprint of this root right here. So it started out as a very, very small failure, but it bulked up as it went down this steep slope, reached the channel of the creek, and then took off at very high velocity down the creek and across the highway. And that little red dot on that image is the house above the level of the stream. It wasn't down right next to the stream. It was above the level of the stream. This debris flow ran up over the channel wall and completely destroyed that home. Terrible tragedy. So that's another type of event that I'm kind of skirting the issue of landslide damming, because these represent real hazards and risks to people living in British Columbia. They're very common, and they typically occur during heavy rainfall, but they don't produce the type of damming that I'm going to illustrate very shortly. And then we have the very largest failures. We have had some big rock slides. Ramp slide is a classic, iconic example of one of these. In Europe, they're called stoop storms, which are streaming masses of rock. They are different from rock slides and typical rock slides in that they go way beyond where they're supposed to. There's something going on in the interior of a rock avalanche that allows them to reach much farther out beyond the base of a slope than would otherwise be the case. And that's the example shown here. The debris has come off Turtle Mountain and run across the valley floor on which Frank was located, the town of Frank, and streamed well beyond where most people would have thought it was possible. So these are yet another kind of variant of what we call rock slides. And then an example of what we call a slump, which is a rotational failure. You can see it quite clearly in this example. We're just downstream of Ashcroft, a community you can see in the distance in that photo is Ashcroft. And that failure that's kind of illustrated by the darkened scarp and then the rotated block occurred in the late 1800s. Didn't block the river, but potentially events like that, if slumps are big enough, they can do that. Now I'm going to kind of shift gears a bit and talk about landslide dams. So I've talked a little bit about different types of landslides and tried to emphasize what types of landslides are capable of damming streams and rivers. I wanted to show you the gold medal winner of landslide dams, which is in Tsilhqot. And this is the Usoy landslide, which occurred during a big earthquake back in the early part of the last century. And the rock mass that failed on the slope, you can kind of make out where it is on that image. It's right at the end of the lake. Was huge. It was far larger than anything we've ever had happen in British Columbia. And it blocked the valley, blocked a river valley with debris up to 500 meters thick and form that lake behind it, which is many tens of kilometers long and several hundred meters deep. That lake didn't exist prior to that landslide. And of course, people after this event were very concerned because they didn't know how stable that dam was. You know, imagine all that water being released if the dam were to fail. Well, you go downstream from there and there are millions of people living on floodplain of the rivers that kind of drain that area. So at the end of the day, they kind of keep an eye on it. The dam has been stable for over 100 years. And I don't know, you know, there's no thought being given to draining the lake. That would be a major costly endeavor. And keeping it empty would be a problem. You cannot remove that massive debris, which is many cubic kilometers in volume. It's not going to happen. So I thought I would show you the classic world record holder, you know, just like the Olympics of landslide dams. This is the gold medal winner.
If you don't mind, I think Rod have a question for you. Rod?
Yeah, I did have a question actually. Something I sort of said in the chat, but I was just wondering, do you personally have a idea or prediction for how soon one of these may happen again and where and how devastating it will be?
Thank you. I'm going to kind of come to that topic. I can't predict exactly when one will occur. And certainly of that size, I think it's probably not going to happen. That's such a huge event, but that doesn't mean that we can't get quite large blockages along, say, the Fraser River. And I'm going to touch on that, and you can be the judge. You know, it's really quite difficult, if not impossible, to predict exactly where these huge landslides are going to occur.
Yeah, I know you can't make exact predictions, just if you wanted to touch on that at all.
I would say that, you know, I'll turn to this in a little while, but these types of blockages where you have reservoirs forming upstream of dams are super common. So I think we can expect them easily on a decadal time scale.
So you said 10 years or 5 years, is that what you said?
Well, it's a decadal. You know.
Oh, I thought you said 5 scale, like 5 years. Okay, sorry, I misheard you.
Oh, but you know, well, you'll see kind of you know, I'm going to set that up and leave it to you to imagine. That's the reason I think that they're underappreciated is we've kind of never had one that I would call one of these landslides that formed a big reservoir in a strategically dangerous place. Like I would say, for example, in Yale, you know, what would happen if you had a Hope slide coming down into the Fraser Canyon at Yale, just for example. That would be so strategically really getting people exercise, because then you would have to really worry about how stable an impounded Fraser River was behind a dam like that. And so, you know, I'm not saying that's going to happen, but I'll turn to it in just a moment.
Okay, thank you.
Yeah.
So question about the last, the one we were just talking about.
Yeah.
How did it happen?
That one is
Yes.
Chilcotin. It was an earthquake.
Earthquake.
Yeah, it was a big earthquake. I think it was about a magnitude 7.5. And that is a common trigger for big landslides. So another example would be, you may have heard of, is the landslide that formed during the Hebgen Lake earthquake in Montana back around 1960. And there was a very large earthquake in Montana that triggered a failure of a slope that impounded a large river, and still exists. Which is called Earthquake Lake. So you can drive along the shore of Earthquake Lake today kind of see, and it was fatal because there was a campground right at the base of the landslide. So earthquakes, you know, they commonly cause ground motions that can just kind of cause the failure of large rock masses. Not all of them. I mean, many large rock slides occur in the earthquakes. The earthquakes are a common trigger.
Thanks.
So this is a compilation done by a colleague of mine showing where large landslide dam lakes have formed in not only British Columbia, which are the purple ones, but also in the western US, the blue ones, and in Alaska, the orange ones. So you can see they're scattered around. And of course, most of them occur in a very rugged coastal mountain belt. You know, that's where you can get landslides that are large enough that they impact frozen streams. But I'm going to turn to, just as an example of where I think we might have an issue, is the Fraser River watershed, which of course is the largest watershed in the province. It represents 1/4 of the area of the province, and it kind of drains a large part of southern up into central British Columbia. So the area shown in white in this image is the Fraser River watershed. And in particular, I want to talk about the Fraser River Valley. And this is often called the Fraser Canyon. Most people think of the Fraser Canyon as extending from Yale up to Lytton. But in actuality, I'm told by my very astute colleagues that the canyon actually continues northward beyond Lytton up into the Williams Lake area, or even beyond that. And that means that there's a deeply incised valley that's cut into the plateau that has typically steep slopes bordering it. And maybe slopes that are developed in rock, or slopes that are developed in soil materials and in sedimentary deposits. But inherently, these are such steep slopes, and they're so close to the Fraser River itself that you kind of have to worry about a failure, a landslide occurring on one of those slopes and coming down into the river valley. And there's an interesting story as to why Fraser River flows in a canyon. Quite a river of that size doesn't belong in a youthful valley like that. It's geomorphically or geologically a kind of a problem, if you will, because rivers typically, as they mature, they form broader valleys with lesser slopes on the sides. This one flowing in a canyon as it does tells me and any geomorphologist that that river hasn't been in that position geologically very long. And we now have evidence that the Fraser River has only flowed with that volume and discharge over about 1 million years. It still is adjusting its the valley in which it's flowing to this new path. It used to flow northward through Prince George, somehow got through the Rocky Mountains, probably via the Peace, and flowed either into Hudson Bay or into the Arctic Ocean over the sea. Remarkable story. And it sets us up for potentially a big problem, because the next slide will show kind of the pathway of the river in part of that canyon. This is the southern part near Alexandria. And the river there is remarkable because it is deeper than it is wide. And a big river like that should never do that. Never, never. Not allowed. You know, geologically, the river will adjust by broadening its path and reducing its depth. But anyway, that doesn't matter. What's important is that you can imagine the rock slide coming off that steep near vertical wall would cause a big impact. It might dam the river if it occurred during salmon spawning cycle. It certainly, as I'll show you, would be a huge problem for the salmon fishery in British Columbia. So just to kind of illustrate that, and the sort of the map at the left, I think it's is just shows where small landslides have occurred along that southern canyon path. Now, these aren't big ones, but these are areas where small, what I call rock falls, have occurred that have really been non-disruptive because they've been too small. But you can see how many of them there are. It's quite a locus of instability. But now I want to walk you through some of the events that have had a big impact. And this is my geological bias. I, kind of love to put what we see today in the context of the past. And geologists are people who embrace that fourth dimension, not just the three spatial dimensions, but the fourth dimension, which is time. And you've got to take that into account as well. So I don't know how many of you have driven Highway 12 from Lytton to Lillooet. There's a highway that kind of follows Fraser River, and about, I think it's roughly 20 kilometers north of Lytton, the highway crosses the path of the Texas Creek landslide. And that landslide initiated high up on the slope on the right side of that image where I kind of indicated the scarp with a red line and the direction the landslide took off on the arrow, and crossed the river and left that area of rock slide debris, which I colored in pale orange. And, just by kind of your own imagination, you can understand that part of that's been eroded. And originally, when the event occurred, it probably extended across the valley and blocked the Fraser River for some unknown length of time. We do know by carbon dating and also by other types of dating when that occurred. It occurred about 2,200 years ago. It was a long time. There were people, of course, in that area. There were people who depended on the salmon fishery. So one wonders, a blockage on that scale, sort of possibly, probably because of the size of the barrier, disrupting the salmon runs for at least one season, to the point where no salmon would reach higher in the watershed than that point. But, we don't really know in detail. But 2,200 years ago, there was this massive blockage. It's interesting that this occurred at the same time that Mount Meager last erupted, which is about 2,400 years ago. We don't have the precision in dating that allows us to say they're linked, but we like to speculate that maybe they are, that this big eruption that occurred 2,300 years ago and this landslide are linked. So let's move up into historic times. And I want to describe briefly landsliding that occurs along the Thompson River Valley, south of Ashcroft. And all those red blotches are landslides that likely have impacted the Thompson River, which is a major tributary of the Fraser River. And one of them, the one that is linked to the blue arrow to the image on the right, occurred in the 1880s, 1880 exactly, and in fact did block the Thompson River. And Ashcroft, being an old town, existed at that time. It sits on a river terrace just above the Thompson River, and parts of the community are located right on the floodplain. And so this reservoir backed up beyond upstream of that barrier. It persisted for 44 days. Had this remarkable photograph of taken of the level the lake reached in ash trough, which would have covered parts of the community and would have lapped up into the other ones for 44 hours before the dam overtopped and was breached, created a downstream flood. Just I shouldn't go off on tangents, but one interesting thing is when that river was blocked, the placer miners started going out into the channel of the river downstream looking for placer gold because they could get down into the crevasses on the other river channel when there's no water flowing in. The only way you can do that is to dam the river, because they'd love to dam the river. They can't do it, so they relied on Mother Nature to do it.
But did they find it?
I don't know. This is all just something somebody told me. So, and then moving forward still, that was 1880. And then 1914, I touched on this earlier. This was a human caused disaster, if you will. They were building the CN Railway on the slope above Hell's Gate to show, oops, sorry, one slide off, which is shown in this slide. And as a result of the blasting that they did, there was a subsequent large rock fall, probably close to a rock slide, but we'll call it rock fall, that entered the Fraser River at Hell's Gate. And the river channel is already quite narrow there. And the debris cone, which resulted from that failure, narrowed the channel enough that salmon couldn't get through. You know, so I heard stories of, you know, they were probably embellished, it was real. But during the peak of the salmon run in 1914, that salmon were collecting below this barrier. You could walk on salmon, they were so common to get past the barrier. And so it had a big impact on the fisheries and really kind of was something that did not help indigenous colonial relationships at the time. Because of course, you know, engineers for the CN were responsible for the landslide. And then I want to also give you a few examples even more recently. A very large landslide occurred at Mount Meager back about 10 years ago. 2010. And this was the largest historic landslide that we've had in British Columbia. It's about 50 million cubic meters. It was one of these kind of rock avalanche debris flows that came off the flank of Mount Meager, traveled down the valley of Capricorn Creek, and entered the valley of Meager Creek, where it then took a big turn and flowed down into the valley of the Little River. And it dammed two lakes, one in Upper Meager Creek, which is shown by that blue pattern in the lower half of that image, and one just upstream of the debris lobe in the Little River Valley, which is shown by the other smaller pattern. Those were two lakes. There was quite a concern that the emptying or the breaching of the dams would cause flooding in Pemberton and in Mount Curry. And they actually evacuated in 2010 after the landslide. They evacuated Pemberton over concern about a possible flood, which was contentious because the mayor did not evacuate, but that's all. So these are photographs. That's one photograph, and then these are some images that show the debris path, and the one at the lower right shows the lake upstream along the creek that formed at that time. And these types of landslides are, I would call them uber common in the volcanic rocks that we have in the sea to sky area. So Mount Garibaldi, Mount Meager, Mount Clague. These are places where rivers have been blocked repeatedly in the past. And concern would be that it's possible for that to happen again. Some of them in the Squamish Valley would probably have consequences for people in Squamish. Because Squamish is protected by dikes that deal with normal rainfall triggered floods. But they're not equipped to deal with a breaching of a reservoir in a very short period of time. And then moving very close to the present, we had a small landslide and along the Fraser River, a place called Big Bar. And I think you probably remember this one. Happened in 2019. This is an image of where it occurred. Kind of similar to that Fraser River blockage at Hell's Gate, in that it was not a really large landslide, but it did occur during the sockeye salmon run, and sockeye were having difficulty getting past that partial blockage of the channel. So fisheries and oceans were struggling to clear the blockage. They even entertained the idea of using cannons to, blast salmon over that barrier up into more placid waters. Ridiculous. But it took them the better part of 2 years to actually clear that debris. And you can see in this image, the effort that was required, in terms of heavy equipment having to get down onto the channel margin to remove the debris load from that landslide. Now, that was not a large. So this gets into the kind of feeling I have that these can occur frequently on a decadal time scale. And there's just so many places where you can get these types of blockage, which would have a consequence for salmon, if nothing else, possibly for more directly for people living along these streams. And then I did mention the Chilcotin landslide in 2024. This was kind of unexpected. It didn't occur during heavy rain, but it happened very suddenly. It was a slump that came down onto the valley floor and blocked the channel of the Chilcotin River. It occurred in the lower portion of the Chilcotin River Valley, which indigenous people have a name that translates into landslide valley. And landslides are super common. There have been several that have blocked the river temporarily within this general region, the lower roughly 30 kilometers of the channel down into the Fraser River. So there was concern not only about the overtopping of the dam, but also the impact on the salmon run, because again, it occurred just before the peak of the sockeye run. And it's important to bear in mind that the Chilcotin is an extremely important watershed for several different species of salmon. It's one of about 9 large watersheds that form tributaries of the Fraser, and a huge contributor to the commercial sockeye fishery, for example. So there was a legitimate concern. But within a week, the dam overtopped and the river cut down through the debris. And basically, I think, happened quickly enough that salmon were able to struggle past that barrier, which kind of drives me to another point, is how amazing those animals are, how resilient they are, and how they can overcome these barriers in most cases. And so I just wanted to finish up with a few thoughts on impacts of these types of events, which we know are recurring, have happened in post-glacial time hundreds and hundreds of times on salmon. And until really into the colonial period, didn't seem to affect populations all that much. So the salmon are somehow dealing with the fact that their spawning beds are getting disrupted periodically by these blockages, which I think is amazing. So kind of what would be the, just conceptual impacts on salmon, and it's kind of like a science, I say it depends, scientists always do that. It depends on when the landslide happens. Does it happen within or outside the spawning season? It depends on the size of the blocking landslide. Generally speaking, the bigger the barrier, the longer it takes for it to be breached and for the path to be cleared along which salmon can run. And it depends upon the earth material forming the dam. I showed you an example of a rock slide on Vancouver Island where the blocks are so big that dam is there for, an awful long time, longer than we would worry about. And it's not a salmon spawning stream, so it doesn't really bear on this. But, there are some big landslide dams that have isolated upper parts of watersheds from salmon spawning because the barriers are natural and they've been there for an awful long time and they're going to be there for a long time. With a smaller barrier tends to get breached, and within some sort of understandable length of time, salmon are able to return past that breached barrier and recolonize maybe parts of the watershed that were sort of places that could not spawn in for a year or two or something like that. But there are other impacts of landslide damming. Because you have to think about, a big dam on a river causes upstream flooding. So if you have a community above the dam where a reservoir forms, that community is going to become inundated. And that can happen if you have a large enough landslide. It has happened globally in the first place. When the dam breaches, assuming that it does breach, you get very high discharges, larger discharges than you would normally get during the freshet or during rainfall triggered floods, because all that water is flowing out of the reservoir very quickly, and peak discharges tend to be elevated tremendously. And just to return to a moment for the 2024 Chilcotin River landslide, we were fortunate that occurred at the end of July, because at that time, Chilcotin and the Fraser Rivers had passed the freshet period. They were not flowing at their normal snowmelt high levels. And as a result, the floodwaters ramped up, but they did not exceed the peak discharges that you get during a big rainfall or snowmelt triggered flood. Came close, actually. There were places where even the additional water at that low stage in the Fraser River, the additional water came close to flooding properties along the river bank. But we were lucky. I call it dodging a bullet. In many examples where we dodged bullets in British Columbia because of disasters. So the high discharges are important when the dam fails, and they pose, in my view, a threat that we have trouble dealing with to property and infrastructure, both upstream and downstream of places where these barriers might form. And they do pose at least temporary barriers to those resilient creatures that are one of the most amazing organisms on this planet. So I kind of make that point is that salmons are resilient. They return, they basically are kind of programmed to colonize portions of watershed that provide suitable habitat to them. And once those kind of areas open up, they're there, They just managed to do that. And so kind of on that shorter time scale, annual to centennial scale, they pass through the breaches and continue to maintain spawning populations in areas that might be blocked temporarily by these barriers. That's a sort of good news story. You know, kind of part of me says, I'm going a little bit off topic here, is that landslide dams partly are one stressor to salmon. They're an ephemeral stressor, but of course we know in the last couple hundred years how they're being stressed as a result of human activities. And so I just got to thinking, you know, about this and tried to illustrate it in a very subjective way. There's no science here whatsoever. It's just my ideas. You know, prior to colonization, there were these temporary interruptions on it, as shown by the left side on this diagram. This is a time diagram going from the pre-colonial period right up to modern times. And, you know, there were equilibrium populations as far as we know, but they probably were disrupted by things like these landslide barriers, or maybe extreme flood. You know, that's another disruptor where channels of rivers might strip of their gravel, which would be a problem for salmon to respond. But nonetheless, I suspect, hopefully somebody will document this, that for the over 10,000 years that indigenous people were, you know, kind of living on salmon, that there was an equilibrium, sustainable equilibrium population. And then we came along and started to modify the landscape, started stripping forests. We started building roads along rivers, started armoring channels. We were doing all sorts of nasty things. And of course, that and pollution have had an impact. I mean, that's undeniable that the salmon populations are lower now than they were prior to colonization. And so we've seen this decline in overall populations. In that type of world, a major blockage of a river would be kind of a threshold event that would add to the stress that salmon are experiencing. Wouldn't be particularly positive thing, even though it would be arguably natural. So that's one kind of thoughts on that topic. You know, kind of salmon are one thing, but I think we do have to concern ourselves with the possibility that we could experience an unprecedented, very large blockage of a river like the one in Texas Creek 2,000 years ago, maybe on a shorter time scale. We don't know what impact climate change is going to have on the number and size of landslides that are going to occur in the future. That's a bit of an unknown wrinkle at present, but I suspect even in my lifetime, I'm 79, we're going to see another blockage of a river in British Columbia that's going to cause some angst at the provincial level as to how to deal with it. That I'll close off. Any questions you might have or comments? My hearing is not that great.
What about Garibaldi?
Oh, Garibaldi Lake. Yeah. The barrier. Barrier, you're all probably familiar with. It's the terminus of some lava flows that came off Clinker Peak, which is a kind of a small peak in the volcanic complex that forms Garibaldi, and blocked the valley, and so created the basin in which Garibaldi Lake sits. And that happened fairly recently in geologic time. It happened at the end of the last glacial cycle. So there is this quite large lava dam, it's a kind of a big dam that separates Garibaldi Lake from the terminus of those flows, which is the barrier. And the barrier is quite steep. So, there has been some concern. Is it possible for enough of the terminus of the barrier of this lava flow to fail that Garibaldi Lake would drain? And I would say no, it's too big a barrier, but there is a smaller lake called Barrier Lake, which is part of the system of lakes around Mount Garibaldi that is also impounded by the same lava flows. It is much closer to the face where a failure could occur. Well, that's a smaller lake, and it's important to realize that there was a very large rock avalanche or debris flow off that barrier face back in 1855. So there was a kind of a failure there. It went down the channel of Rubble Creek, spread out over the valley floor. Highway 99 crosses that landslide deposit. And if you really observe it, you can see where the Chilcotin River has cut down through the landslide debris and exposed the tree stems that were covered by that event. And that's how we know it. One way we know it happened in 1855, because we can look at the ring patterns in the trees and relate them to old living trees. So there's one place, unfortunately, you got to be quick on your feet, because there's only one place you can really see that as you're coming down close to Rubble Creek from the slope, the rock slope that the highway crosses. But if you happen to be looking, just look off to the left next time you go to Whistler, and you'll see a bunch of vertical tree stems in the channel of the river. They don't belong there. That's because they're ancient. These are trees that died during that landslide. And all that to say is, I kind of don't think there's any danger that Garibaldi Lake is going to drain. But I do think there's a possibility that you could get another landslide like that in 1855 off the face of the barrier. That's a much more realistic kind of event. And whether that would reach back to Barrier Lake, I don't know. Unless I just a lot of questions. Most of them I can't answer.
Well, Dr. Clague, if I may, maybe the questions you actually look at, and because you cover British Columbia, is that correct? Or you consult on landslide everywhere, I'm not sure.
Yeah. These same problems exist, in all mountain belts, really.
And and specifically, I'm interested in permafrost.
Yeah.
Because you would have in BC, and the impact of permafrost is just a.
Yeah.
But they would fall in a different form of landslide.
Yeah. Certain on slopes, it's leading to failures, saturated muddy material within the active layer. And in Europe, they've made a very convincing case that alpine permafrost, in the high peaks, typically above about 3,500 meters, the thaw of the permafrost in the rock slopes is leading to increased rockfall activity. Places like Mount Blanc, the Eiger. They know that because there's so many people who frequent these areas, and any failure is very well documented. So, plus they have a much longer history of kind of recording these events, and we do. Our kind of observational period is much shorter, of course, than it is in Europe. So we're at a bit of a disadvantage, but we do know from measurements that we're leaving permafrost, and that can't be a positive thing for the incidence of landslides of all types, I think.
Deborah, if you have a question, just unmute yourself and you can ask.
Yeah, can you hear me? Am I clear?
Yes.
Yeah, okay. Yeah, I'm a stream keeper on an urban stream, salmon stream in North Delta, and we have a lot of bank undercutting from stormwater flow. Do you have any comments about that? And in particular, I'm wondering, is the sort of the background danger of slides greater than so great that really the stormwater flow is inconsequential? Or I mean, we tend to think the stormwater is an important aspect, but I'd like your observations. Thank you.
Yeah, well, I think it's, kind of in the watersheds that we have in kind of the larger Metro Vancouver area. That's way more important than any possibility of landslides disrupting streams and water quality, because they lie largely outside of these mountainous areas where you can expect to get landslide damming. So landslide damming would not be the issue. You're absolutely right that extreme flows, possibly from urbanization, one has to worry about enhanced peak discharges related to the hardening of surfaces in some of these watersheds, just being asphalted and concreted. That results in less water sort of infiltrating natural soils during heavy rains, and it causes a larger peak in runoff. And that plus the surfaces over which those waters are flowing can be contaminated would be, in my view, much more important than any possibility of damming. And it's tough trying to maintain salmon populations in these small streams, partly because of the increased urbanization, but also other things you're probably more aware of than I am.
Yeah, thank you. That's more ammunition with our mayor and council. We have a lot of rain gardens, rainwater infiltration in rural areas. What about logging? Doesn't the role of logging sort of do a similar thing to paving, in that it reduces the infiltration?
Totally. I didn't touch on that as an issue, but it's related to this post-colonial period that we have clear cut a large proportion of our landscape, the forests in our landscapes. And that has resulted in, surfaces that do then support renewed growth, but for a fairly long period of time, a decade or more, those are surfaces on which you get enhanced runoff. You do not get the infiltration that you get in a forest with a normal canopy, where water is being intercepted by the tree itself, the trees. Instead, it strikes the ground. Some of it may infiltrate the ground, but a lot of it just runs right off as slope wash and then enters stream channels. My view is there's some evidence that the disastrous wildfires in 2023 contributed to the spikes in runoff, particularly along the, see if I get this right, the rivers that flow through Merritt. Names can't remember right now, but there's a few rivers that flow through Merritt. Some cold water.
Yeah.
And that was shocking to people. The residents in Merritt said they couldn't believe how fast in that atmospheric river the rivers rose and escaped their channel. They barely had time to get out of their houses. And that was partly, I think, exacerbated by the forest fires that had occurred in the same watersheds the previous summer. That land was parched and burned, and there are people, some scientists have looked at this and said there might be a link between those two. So clear cutting on a large scale definitely impacts the rate of runoff. And I don't know how that plays out in terms of landslides, the subject of this talk, but it certainly impacts runoff and kind of increases, I think, the magnitude that a flood has, you know. Typically, floods damage is a function of the peak discharges, the maximum discharges that occur, and the duration as well. But peak discharges can often be the real killers.
Thank you.
Questions, Adam?
Yeah, there are some questions. I mean, if you have a question, please feel free to unmute yourself and ask.
ABC slide that happened during, I think it's up there.
Yeah, on the highway.
On the highway, it's
Fairly
still-
accurate, River.
Yeah.
So was that a rock or was that a debris?
You mean in particular?
Yeah.
Much of it was just straight channel flooding, but the fatalities that occurred on the Duffy Lake Road were a result of a debris fall. You know, kind of that highway between Pemberton and Lillooet, there were 4 or 5 people who were killed by a debris flow that came off a deforested slope and came right across the highway. And they were wrong place at the wrong time, but nonetheless, it was a classic example of one of those debris flows like you get in Lions Bay. In this particular case, I think that you can't totally blame Mother Nature. Yes, there was heavy rainfall, but the landslide initiated along a logging road, deactivated logging road that hadn't been properly culverted. So there was water flowing down the road over the edge. And that's just where the landslide started, with a heavy runoff. That basically, again, was a small initial failure, but because the ground is so saturated, it folds up into a monster, you know, and then can travel long distances. They're very mobile, but the long distance. So, but most of the other examples that I'm aware of are a product of just high channel. You know, the damage to the Coquihalla Highway was not landslide related. It was more related to the extreme discharges along river channels in that particular case.
When you get all that much sediment in the system, how do the salmon manage to get back up?
Yeah,
Like because it must not be good for the gills.
biologists. I do marvel at them. I know, for example, in Glacier Bay, it's an area that's rapidly losing its snow and ice. So glaciers that used to flow into the Glacier Bay and form a nice cavity and fronts, you know, the cruise ships love, they're now moving back into more mountainous parts of the area and opening up stream channels. And the salmon are there, you know, it's like, as soon as the ice goes, hello, I'm finding something really nice here. Good salmon spawning channels that are remarkable, you
I
know.
think we need a cheer for our brave salmon. Hooray.
Yeah, no, I just marvel, like, you know, what they can overcome. And, you know, if they have vibrant enough populations, they're certainly gonna occupy areas that were formerly off limits, possibly because they were covered by ice. Admittedly, the salmon can't deal with that, but they can deal with a lot of other things. So there's a really nice paper that's been published on that on a larger scale in the Alaska Panhandle, saying that, you know, because many of the former mouths of valleys were until very recently covered by glaciers. And the glaciers have now receded, and that they're actually documenting how salmon are coming back and occupying, you know, the ground that now is free of ice.